Hey, everybody. In this lecture, we're going to talk about opioids, sort of. And so opioids, an expression that, or a term that most of you probably heard, things like heroin, morphine, hydrocodone, so forth. Narcotics, monitored by the DEA, things like prescription drugs such as Vicodin, Percocet, things like those. Opioid overdose is an opioid abuse in general, very big problem and very hot topic in the whole country these days. And it turns out, well, or if you didn't know this, opium is a natural substance derived from the opium poppy. All opioids actually have very, very similar structures that only differ by one or two functional groups. And that's where the lead in is and why they're relevant for our discussion here is as we start talking about functional groups. Functional groups are different structures, different parts of a molecule that really lend it its chemistry. And so when we look, for instance, at different opioids, we can see the structure of morphine here. So this is the primary component of morphine. We can see the difference between morphine and codeine. Really, the whole thing, the whole structure is the exact same, except for right here, hanging off this aromatic ring. In morphine, it's just an alcohol here. In codeine, it's what we call an ether. And we're going to be talking about those in those types of functional groups in the next lecture when we're looking at different types of what we call functional groups. Then the difference between codeine and hydrocodone. Codeine and hydrocodone are identical with the exception of this alcohol group on codeine is what we call a ketone here on hydrocodone. And so very, very, very similar structures, but they lead to different effects in the body and they lead to different levels of addictive capabilities as well. And so just from small differences in those structures, I mean, really here, the only difference is instead of an H hanging off this oxygen, it's just another CH3 group. But that can lead to very different properties because that's a different functional group. And that's the key, what we're going to key in on these next few videos is looking at different functional groups, the types of groups that exist, and looking at how we name some of them. Because many organic compounds, what we focus on so far is just hydrocarbons. And so carbon compounds that have just carbon or hydrogen in them. Many organic compounds all contain atoms other than carbon and hydrogen, things such as oxygen, nitrogen, sulfur. When it comes to organic compounds, we call these heteroatoms. A heteroatom is anything that is not carbon or hydrogen. A functional group is a characteristic arrangement of atoms and bonds that functions in a very specific way. And so something like alcohols, which will be one of the first functional groups we talk about tomorrow or in the next lecture. Alcohols are described by having an OH group attached to them in some way. That OH group really defines how that compound's going to react and how it's going to behave, no matter what else is attached to it. It might be just a single carbon attached to it. So you might have, and so maybe here's our single carbon right here attached to an alcohol. That would be the simplest alcohol, just CH3OH. That's methanol. Is going to behave pretty similarly, actually, to ethanol, CH2OH. Because really what's the driving force behind their chemistry is this OH group, that OH functional group. Okay. We've already actually discussed some functional groups, the hydrocarbon functional groups, alkenes, alkynes, and aromatic hydrocarbons. Those are absolutely considered functional groups, again, because their chemistry, how they're going to behave chemically and those chemical properties are going to be driven by the fact that this double bond exists or this triple bond exists or this aromatic functionality exists. So we've started to look at some functional groups already. It is important to note that when we're writing a skeletal structure, all heteroatoms must absolutely be shown. And so remember, in skeletal structures, we don't draw in carbons or hydrogens. Every point or vertex is assumed to be a carbon, and there are assumed to be enough hydrogens hanging off those heteroatoms, or sorry, hanging off those carbons. But all heteroatoms are absolutely shown. And you can see that here. Here's what we would call dimethyl ether, and we're going to talk about all these naming rules and how we would name this. But sorry, yeah, diethyl ether. So this would be our Lewis structure for it. And then this would be our skeletal structure. And you can see that we still show that O in there. Not only that, but we also typically will show hydrogens if they're attached to heteroatoms. We don't show the hydrogens in a skeletal structure attached to the carbons, but we do show hydrogens that are attached to heteroatoms. And so again, in the example of an alcohol, so here's a skeletal structure of an alcohol. And so I don't show, we don't draw in these hydrogens here like we've talked about. Those are assumed to be there. However, the O, that's the H that's attached to the oxygen, the hydrogen on the oxygen, that we do show. Or in what we call a thiol with a sulfur, that's an SH, we would show that hydrogen. In amines that have nitrogens, typically with maybe an NH2, we would show those hydrogens. And so hydrogens attached to heteroatoms, we do show. Sometimes we even don't show these, our non-bonding electrons, our lone pairs in a Lewis structure, or sorry, in a skeletal structure. We'll quite often leave those off. It sort of depends there on what we're trying to show. There might be times that we're trying to show the details of a chemical reaction in which those non-bonding electrons play a role, and so we'll show those. But if we're just trying to depict a compound, then quite often we'll leave those off. And so the diethyl ether that you see here, you might often see that simply written just like this without those lone pairs attached. Oh, and I forgot that I actually talked about that right here. All hydrogen atoms bonded to the heteroatoms, again, must be shown. We only omit hydrogen atoms that are bonded to the carbon atom. These are the different functional groups that we will be studying. We're going to see this R quite often. Just know that R means that can be anything else. Any other sort of carbon chain could be hanging off that. And so we use that as an abbreviation. And so if we have any sort of length of carbon chain, depending, and it could be branched, could be whatever's going on there, any sort of carbon chain with an OH attached, that's an alcohol. If we have an oxygen with two different carbon chains hanging off either side, that's an ether. An SH, it's called a thiol. A carbon chain with a nitrogen attached to it is called an amine. And I didn't put the H here because, as we'll see when we talk about amines, we can have what we call primary, secondary, or tertiary amines. And so on the other side of this nitrogen, there might be two hydrogens. There might be one hydrogen and another R group. There might be no hydrogens and two different R groups. So again, just to kind of show what that might look like. So we might have, again, anything for a carbon chain over here, then a nitrogen, and there might be two other hydrogens coming off that. We might have one hydrogen and something completely different for an R group. We might have something like this with three completely different R groups hanging off of a nitrogen. These are all still different types of amines. And again, we'll look at all that terminology when we talk about amines in a later lecture. We also have different types of carbonyls, and it was a little tough for me to write that into the PowerPoint slides here. But the key to a carbonyl is that we have a C double bond O. And so somewhere within the molecule is that C double bond O structure, and then we'll have different things hanging off that carbon. So one of these R groups here might be a hydrogen. One of them might be something else. And then when we talk about carbonyls, that's what we're going to discuss is what those is different types of carbonyls essentially mean that these R groups here are different. And so this is just a quick video just to intro us to functional groups, what they are, the different types of functional groups that there are out there. In the next couple of videos, we're going to start to focus in on different functional groups, things like how we name alcohols, how we name ethers, how we identify them, and really starting to look into detail at some of the different functional groups. And so that is it for now. And that's just the way functional groups work. Thanks for watching.